Hi and welcome to this video for the BTEC Applied Science Level 3, Unit 1. So, going through moles, molar masses and molarities section. First off here, we've got a no statement. So 1 mole of any substance contains the same number of particles as there are atoms in 12 grams of carbon-12. So this is essentially referring to the relative bit that we know about the periodic table. So carbon-12 is taken as the standard, and we say if we've got 12 grams of carbon-12, then that's 1 mole. So the number of particles within that, if I counted every single little carbon atom and I added them all together, it's this big number here, what's known as Avogadro's constant. That means if I took 1 mole of any material, then it's always got this number of particles in it, whether it's 1 mole of oxygen, water, methamphetamines, etc. It's always got Avogadro's constant there. So generally that's just a little definition to be aware of. Avogadro's number, that number there, 1 mole, and it's the number of particles within 12 grams of carbon-12. Now, next bit here, being able to convert moles into the number of particles using the Avogadro's constant. Right, so number particles equals moles times Avogadro's constant annoyingly has 2 symbols, so it could be shown as either of those. You don't need to overly worry about remembering both. Chances are in the exam it will just show you. So that is Avogadro's constant there. And as we can see, the number up here. So in terms of if I say 3 moles, then all we simply do is 3 times 6.02 times 10 to the power of 23. And if I get a calculator and do that, then we've got 1.806 times 10 to the power of 24 particles. And likewise, if you've got half a mole or 10 moles, things like that, all you're doing is multiplying it by this number. So it's what's referred to as the chemist dozen. You can basically just imagine this as being the number 12. It's just to avoid using stupidly big numbers like this. So if you say 3 dozen, then just imagine dozen in there. 3 dozen, you would just do 3 times 12 and you'd get the answer 24. So that's all you're doing. It says though being able to do it in reverse, so you need to be able to rearrange this equation. You can imagine it as the little triangle if you're still struggling with rearranging equations. First off though, obviously just practice with that. It is an important skill to learn, but just for memory wise, you can do it like this. So if you're given, say, the number of particles and you're asked how many moles you have, then what we could do is moles is the number of particles over Avogadro's. For some weird reason, I did the hashtag symbol the other way there. So let's say we've got 3.01 times 10 to the power of 23 divided by 6.02 times 10 to the 23. Then that would come out as 0.5 moles. Now the next bit, know the molar mass of a substance is the mass in grams of 1 mole of the substance. So yeah, what it's more or less saying is if we've got 1 mole of carbon-12, then that's going to be 12 grams of that material. And likewise, if you've got, say, 1 mole of water, then finding the MR of that. 1 mole would be 18 grams per mole. Now, know the molarity is the number of moles of a substance dissolved in water, so further videos deal with concentration a bit more, but essentially concentration, its unit is mole per decimeter cubed. So let's say you've got a beaker and it's got 1 decimeter cubed within it. If we say 5 moles per decimeter cubed, that means I've got 5 moles. Bear in mind, I'm just avoiding drawing all the particles, so we'll say each of these are 1 mole. 5 moles floating around in that 1 decimeter cubed. Those would be my 5 moles within there. So say if I took half that volume, I cut it in half like that. Even though I'm just taking 500 cubic centimeters, the concentration is still the same. If we look at sort of the density of it, I would get the 2.5 moles within the 500 cubic centimeters, but the concentration doesn't change. So say if you've got a cup of orange juice, you pour half of it out, so you drink half of it, the other half would still taste exactly the same. You've not changed anything about it, you've not diluted it, you've not added more of the concentrate, so on. So concentration is basically just a measure of density. Okay, thank you.